Welcome to Zoom in Data. In this session, we are learning about Databricks structured streaming architecture, which explains how Databricks processes real-time data reliably. Structured streaming is used when data arrives continuously and insights are required quickly. Understanding its architecture helps beginners clearly explain how real-time pipelines work and helps professionals design fault-tolerant streaming systems. This topic is very important for interviews because real-time processing is widely used in modern data platforms. Subscribe to Zoom in Data to keep learning Databricks in a structured and interview-focused way. What is structured streaming in Databricks? Structured streaming is a Databricks framework used to process continuously arriving data. It treats streaming data as a table that keeps growing over time. Developers can use Spark SQL and DataFrame APIs for streaming logic. This unified approach makes streaming easier for beginners to understand. Why is structured streaming used in Databricks? Structured streaming is used when data needs to be processed in near real time. It allows businesses to react quickly to incoming events. The framework provides built-in fault tolerance. It ensures consistent and reliable processing results. What is the architecture of structured streaming? Structured streaming is built on top of Apache Spark. It processes data using micro-batch or continuous execution models. Progress and state are tracked using checkpoints. This architecture supports scalability and reliability. What is a micro-batch in structured streaming? A micro-batch is a small chunk of streaming data processed periodically. It allows streaming to internally behave like batch processing. Micro-batches simplify error handling and recovery. They balance processing latency and stability. What is continuous processing in structured streaming? Continuous processing is designed for very low latency use cases. Data is processed almost immediately after arrival. It reduces delay compared to micro-batch processing. Not all streaming operations are supported in this mode. What are streaming sources in Databricks? Streaming sources are systems that generate continuous data streams. Common sources include Kafka and cloud-based event services. These systems send data as messages or events. Databricks reads this data in a structured format. How does Databricks read streaming data? Databricks continuously monitors streaming sources for new data. A predefined schema is applied while reading the data. Data is processed in the order defined by the source. The streaming job runs continuously until stopped. What is a streaming sink in Databricks? A streaming sink is the destination for processed streaming data. Common sinks include Delta tables and cloud storage. The sink stores results produced by the streaming job. This data can be used for analytics and reporting. How does checkpointing work in structured streaming? Checkpointing stores metadata about processed data. It tracks offsets and execution state. Checkpoints are saved in reliable storage. This allows the stream to resume after failures. Why are checkpoints important in streaming? Checkpoints prevent reprocessing of already handled data. They help achieve exactly once processing semantics. Failures do not cause data loss. Pipeline reliability is significantly improved. What is stateful streaming? Stateful streaming keeps track of intermediate results across batches. It is commonly used for aggregations and window operations. The state is continuously updated as new data arrives. Proper state handling is critical for performance. What are stateless streaming operations? Stateless operations process each record independently. They do not store any historical information. Filtering and simple transformations are stateless. These operations are easier to scale. What is watermarking in structured streaming? Watermarking helps manage late arriving data. It defines how long the system should wait for delayed events. Watermarking limits the amount of stored state. This improves performance and resource usage. How does structured streaming handle late arriving data? Late arriving data is processed using event time logic. Watermarks define acceptable delay thresholds. Data arriving too late may be ignored. This ensures accurate and efficient results. What is exactly once processing? Exactly once processing ensures each record is processed only once. It prevents duplicates during retries or failures. Delta Lake supports this guarantee. Accurate analytics depend on exactly once processing. How does Delta Lake integrate with structured streaming? Delta Lake provides transactional consistency. Streaming writes are handled atomically. Schema enforcement is supported during streaming ingestion. This integration improves reliability. How does structured streaming scale? Structured streaming uses Spark's distributed execution model. Data is processed across multiple worker nodes. Autoscaling adjusts resources automatically. This supports high-throughput streaming workloads. How does structured streaming ensure fault tolerance? Spark automatically retries failed tasks. Checkpoints preserve progress information. Jobs can restart without data duplication. This ensures continuous pipeline operation. What is a trigger in structured streaming? A trigger controls how often data is processed. It defines the frequency of micro-batch execution. Triggers affect latency and throughput. They help tune streaming performance. What is processing time versus event time? Processing time refers to when data is processed by the system. Event time refers to when the event actually occurred. Event time processing provides more accurate results. Structured streaming supports both concepts. How is structured streaming monitored in Databricks? Databricks provides built-in streaming metrics. Processing rates and delays can be observed. Logs help identify errors and performance issues. Monitoring ensures long-running stability. What are common use cases of structured streaming? Real-time dashboards rely on streaming data. Fraud detection systems use real-time processing. Log and event analytics use streaming pipelines. IoT data processing is another common use case. What are limitations of structured streaming? Stateful operations can increase memory usage. Very low latency requires careful tuning. Continuous mode has limited functionality. Resource planning is essential. Why is structured streaming important for interviews? It demonstrates understanding of real-time systems. Interviewers assess fault tolerance knowledge. It reflects real-world data engineering tasks. Strong answers show production-level experience. How does structured streaming support business analytics? It enables faster insights from live data. Businesses can respond quickly to events. Data remains consistent and reliable. Decision-making becomes more timely. Thank you for watching Zoom in Data. If you found this video helpful, like, share, subscribe. More Databricks interview and tutorial videos coming soon. Stay connected and keep learning with Zoom in Data.